We are now going to look at the Pythagorean theorem, but look at it with like 3D objects, other figures, word problems, try to make it a little bit more challenging. So we're still going to be looking at the Pythagorean theorem this week, but let's make it a little bit more challenging. So here I have two parts. I'm going to do a couple of these problems with you just to kind of show you the way, and then you need to put your answers, just like we have been doing, down here, and then you would turn it in, submit it to me, so then I can just check it over. So part one. These are all 3D objects, right? And it doesn't always have to be these cubes or rectangular prisms. We can look at other ones that still have right triangles within them, but we're going to look at these four today. They want us to find this missing x, right? So that's really what the question is find this missing length x. And you see how it's a diagonal inside this cube or prism. These are all just rectangular prisms. None of them are cubes here. So this is how you do it. you're going to have to do the Pythagorean theorem a couple times here. So what I would do is I would say, okay, I need this length. I know that I can create a right triangle here, right across like this. You got to use your imagination there. So look at this right triangle that's within there. Here's the right angle, and it's kind of just in the middle of that rectangular prism. Now, I know this length right here, this vertical length is 7, right? But I do not know this one. This is another diagonal across, but I can get this one. So this is where you have to do the Pythagorean theorem twice. I will use this color, and I'll show you another right triangle to get this diagonal length, because we know this length to be 7, right? So let's say we write 7 in there. That's 7. Put a little cross there. All right, so that's 7. We now need to get the other diagonal length so we can then use the Pythagorean theorem to get this last one. So look at this other triangle I just made. So I made one down below where I know my two legs here. This is another right triangle, and I know this length to be 6, and the other length we see already is labeled down here as 8. So I would then do the Pythagorean theorem right here with these two legs to get this hypotenuse, the one that's across from the right angle. And then once I get this hypotenuse of this bottom triangle is actually a leg of this triangle that's floating in the middle of this rectangular prism. So I would do 6 squared plus 8 squared equals c squared. And when you do 6 squared plus 8 squared, and then we don't know it, it's the hypotenuse that's across from that right angle, we would know this to be 36 plus 64. So 36 plus 64 is 100, and that equals c squared. And then remember with the Pythagorean theorem, we always have to square root at the end. So I'd square root, and we know that missing length is 10. So now I know, let me erase this real fast. Let me get rid of all these numbers here and these arrows. Okay. So now I know that that length, that hypotenuse that we just found, is actually 10. So then I can do the Pythagorean theorem again now, 7 squared plus 10 squared. So I'll do 7 squared plus 10 squared equals c squared, because now that x is my c. Or you can put x squared if you want, doesn't matter, because that's my hypotenuse again. It's the one across from that right angle. So this would be 49 plus 100, so that's 149. And then we'd have to take the square root of that. You can round, or you can leave it as the exact answer. That's just for simplicity's sake, so you don't have to use the square root when writing in your answers. Let's round it. So let's take the square root of 49. So if I took the square root, square root of 149, I would get about 12.2. Square root both sides, about 12.2. And that's what I would then type in down below. That's equal to C. So you see you have to do the Pythagorean theorem a couple times to get to that middle diagonal length. So these are all very similar where you have to do that same idea. I'm just using different numbers, so get used to that. Now the second part here is just some figure problems. So part 2, you're going to have to use the Pythagorean theorem, but then also use what they're asking for, right? So in this one, we know these are all squares. We know this length is 6 feet, so that means each one of these squares has a length of 3 feet. They want to get these diagonals here, and you got to count how many you have to see how much tape that she needs. So just kind of using the Pythagorean theorem once, and then getting that diagonal length, and then multiplying it by however many pieces of tape you see there. And again, round your answer to the nearest whole number for the amount of tape. And then we see these two. This one, Georgia buying a snow cone shaped like a cone. What is the height of the cone, right? So you got to think about, all right, if I drew this in here, right here, they're looking for this height. And again, we see the right angle formed right there. So you're actually given the hypotenuse, and you can actually get this length of this leg. You're looking just for this height. So using the Pythagorean theorem, a little bit different than the one up above because now we're finding a leg instead of finding the hypotenuse. So write your answers down below and turn this in. And then we're going to challenge ourselves on Khan Academy. I'm going to have a different activity as well called He Said, She Said. See ya.